Good afternoon, everyone. Thank you all for joining us today in our weekly webinar series. Today we're going to talk about an overview of connector inspection and cleaning. My name is Jessica Petrohoy, and I'm the marketing coordinator at fiberoptic.com. Fiberoptic.com is a leading provider of fiber optic products, training, and rental equipment. We're pleased to present this topic to you today. With us today to talk about connector inspection and cleaning is Joe Cairone. Joe is a product manager for the Adtell Group and supply chain and logistics leader with over 20 years of hands-on experience, coupled with outstanding success streamlining operations across a range of industries. Joe will be discussing the importance of proper connector cleaning and inspection and the various methods available. When Joe is finished, we'll take questions from the GoToWebinar question box at the bottom of your screen for a question and answer session. So if any time throughout the webinar you have a question, go ahead and put it in the question box and we'll get to them at the end. And remember, our webinars are always posted at fiberoptic.com/webinar. So thank you again for joining us today, and at this time I turn the presentation over to Joe.
Thank you, Jessica. Welcome. Thank you everybody for attending our webinar today, and I'm going to get right into our presentation here today about connector inspection and cleaning. I'm going to go over about 5 different areas today, starting with connectors, then we're going to go over polishing, go over connector contamination, then we'll hit methods of connector inspection, and then methods of connector cleaning. As you see in this first slide here, we have a bunch of different types of connectors. The main feature you want to come away from this is there's 2 types of connectors, and these connectors, when I say 2 types of connectors, you have your 2.5 millimeter ferrule connectors and your 1.25 millimeter ferrules. They represent about 90% of all connector types that you're going to see out in the field. And again, this is from the ferrule standpoint. There's other connectors that are not shown here. There's not military style connectors. There's not termini. These ferrules may be different sizes, but there are a lot of these types of connectors that still use that 2.5 millimeter or 1.25 millimeter ferrules. Top left hand of the corner of the screen we have FC or Frank Charlie connectors. Middle top we have SC or Sam Charlie connectors. Top right we have ST or Sam Tom connectors. And these again are your 3 basic 2.5 millimeter ferrule connectors. Below those, bottom left, we have your LC or Larry Charlie connectors. Next over we have your MU in the center. And at the far right bottom, you have your MTRJ connector style. That MTRJ has 2 fiber ferrules inside that connector for dual purpose. Next on the screen, you see the different types of end-face polish style connectors that you will come across. Again, these represent about 80 to 90% of the polishes that you're going to see out in the field. Starting at the top, you have flat, and working your way down, you have your PC, your XPC, UPC, and APC. PC stands for physical contact, so that's where that type of connector specification comes from. The main thing that I want you to take away from this slide is under the specification, the 3rd bullet point down on each of the bottom 4 connectors is the back reflection reading. And you can see for the PC connector we have a greater than negative 30 dB back reflection. Just to review our numbering systems here, the higher the negative number, the better the back reflection, meaning a smaller amount of radiation or energy is reflected back from where it originates. And that's what we want in our connectors. We don't want reflection of the signal back towards the equipment, back where the opposite the way in which the signal is propagating down the fiber, because that can cause attenuation and loss and also errors in your data that may be streaming through that fiber connection. The other thing that I'm going to throw out there is the PC is generally used for multimode connectors, and to this point in time is even starting to fade away as far as the polishing parameters. Even the XPC, you don't see that as much anymore. The basic two styles of polish that you do see are your UPC and your APC, and they're going to be about 90% of all connections that you see out there. And it's just based on the parameters of how they are polished. And again, you want that negative 55 dB, sometimes negative 65 dB for your UPC finish, and then, negative 70 plus on your APC. Again, that higher negative number is less back reflection, and that's what you're trying to go after. The next slide you see here is to do with the correct type of polish, or not really the correct polish, but the 3 parameters that are used in determining a proper polish. You have your apex offset, your radius of curvature, or your undercut or protrusion. The apex offset, as you can see on the graph, is denoted by the dotted lines. And what that is saying is there's a theoretical center of your ferrule in which the fiber comes up through. And based on the radius of your polish, which all connectors have that radius on them, you want that theoretical center to be at the top or apex of the radius. And that'll put the fiber directly in the center of the connector so that when you have another connector mating up against it, you'll have good transfer and there won't be misalignment. Second parameter is your radius of curvature, as I said. That is, all connectors that are polished have a radius of curvature. And that's to reduce the amount of surface area that's on the end of the connector where you have that physical contact of the two connectors that are mating up with each other. Just to let you know, when two connectors come together and they click into place in an adapter and mate, there's about 40 to 45,000 psi of pressure. So, and it's because of that small surface area that's touching that makes those pressures so high. So, the less surface area, the better, because that physical contact we want to keep away. We want to make just basically the fiber connections contact each other. And then the next parameter is your undercut or protrusion. And what that has to do with is during the polishing process, you can have the fiber stick up past the ferrule surface, which would be protrusion, or it can be polished away such that it's below the surface of the ferrule. Both are acceptable as long as they meet the criteria or parameters. And I will show you in the next slide, we'll show you what those parameters need to be. So as you see in this slide, you have, these are the IEC specification for the proper polish. First column is your radius of curvature. Second column is your fiber height, or that's your undercut or protrusion. That's how far the fiber sticks out of above the surface of the ferrule or is polished below. And then again, your apex offset. So as long as all of these parameters are met within the specification, whenever you have two fibers that come together and are mated, you will basically have a very good operating connection. So it can be somebody that polishes it, you can get it from two manufacturers, and as long as they meet that specification, once you put those together, you should be in good shape as far as the parameters and operation of the connection. Now we're going to take a look at a little model here that shows what happens during an actual fiber mating. You can see here we have a fiber connector, and actually is an LC off to the left-hand side here. shows the alignment sleeve, which is your split sleeve, some people call them, made of zirconia material, which is a ceramic material. It shows your ferrule coming out of the fiber connector. It's also made of ceramic or zirconia. And then you have the fiber that's in the middle of all of that. So now what we're going to show is another connection coming in from the right side of our connector. And that comes in, and you can see in that oranged area there, that rectangle, you have a physical contact. Again, two fibers are coming together and they're touching. Ferrules are coming together and they're touching. And just as a side note, when the actual glass, the fiber, touches, it actually flattens out from all that pressure. So that's what that whole thing about the physical contact is. Through any connection type scenario, that's your weak point in most fiber networks, because that's where dirt issues, alignment all come into play that can cause a problem in your fiber network. So that's why you try to, this whole point of cleaning and making sure that you inspect your end faces comes to play here, because you want to rule out where most of the problems occur. Three basic principles have come up here with the 3 Ps to ensure a proper fiber optic connection, perfect floor alignment, physical contact, and a pristine connector interface. Just the manner in which the way products are manufactured nowadays, ferrules are very, very high quality compared to 15, 20 years ago, as well as the split sleeves. And just the manufacturing process has gotten to the point where these connections are very repeatable. So generally, it's not the connection that's causing you the problem or the components that make up the connector, but the dirt, the scratches, the other stuff that we're going to review as time goes on today in this presentation. So you can see here, everything is perfect. We got a perfect core alignment in this picture. Physical contacts there. You can see how I was talking about the apex offset, where the end faces of the ferrules are radius. You can see how that's directly in the middle there. And then you have your, there's no dirt in the way. You're going to have a very good signal that's going to be passing through. And let's see what happens here. When we come across a bad fiber connection due to dirt, particle, particulate, see what that happens. It's going to give you a little model. It's going to show you what happens during this mating. So you have dirt on the end, comes in, and it's just like as if you were looking out a window. It has dirt on it. You can't see through it, and even sometimes you'll see a reflection in that dirt. You'll see yourself. That's what's happening. You got signal going out, and it's hitting that dirt, and it's reflecting back. And that's what causes your attenuation, signal loss, data errors. So that's why it's very important to clean your end faces. So what kind of equipment is out there for us to determine what our end faces look like? These are the basic ones that are out there, and pretty much this is what's there, and you can use the device that best fits your need, but in certain cases some are better than others. So in the top left hand you see an inspection microscope, and that's your basic. You put a fiber connection in one end of it, and you can inspect by looking through the eyepiece at the other end. Bottom middle, you have an inspection scope that has many different tips. You can plug into a computer, you can plug into a tablet, and that can save your results that you see on the screen. And it also does a pass-fail analysis. So that's your highest end of the inspection scopes. And then in your upper right, you have a basic inspection probe that can inspect connectors and also adapters. It's got its self-contained inspection viewing port there, and you can also save data or the pictures that you capture on that unit, and you can download it onto a computer. So let's go over some advantages and disadvantages of each of these pieces of equipment. Fiber microscope, like I said, it's the basic one. They come in 200x, 400x. Again, the 200 is from a spec that was really introduced 10, 15 years ago. Most people, if they have any of these inspection microscopes or fiber microscopes, are using the 400x models just because you need to be able to see to that level. It's better magnification. The drawback with this one is you cannot inspect bulkhead connectors. You can only inspect cable assemblies. So that's the drawback from this one. And you're also actually looking through a microscope into a connector. So by chance, if the laser's still on, you're going to irradiate your eye. So in this case, these are good if you need to do a quick inspection on just cables themselves or patch cords, and you want to do a quick check before you mate. They're good because if you're doing it in that manner, you know that there's no equipment hooked up to it where there could be some laser radiation. Next we have is our video inspection probes, both types here. You can see this particular unit at the bottom is plugged into an OTDR. So a lot of times when you're doing OTDR checks on dark fiber, you want to inspect the end faces. Well, you can use your OTDR, but you can also add the inspection probe to this piece of equipment, and you can use this as your video screen. You don't have to carry a tablet or another computer around. The inspection probes, come with a variety of tips. In fact, the one on the bottom, the Pro 45, VIP 45, it's got, I think, close to 100 different tips. The unit to the right, upper right there, that has about 15, 20 of your basic tips that you're going to use. So that'll cover, that generally covers about 80-90% of what you're going to see out there. But the main thing with these two probes is you can inspect and you can document with both of these. So once you inspect these connectors and deem that they're pristine and they're ready to be handed over to your body that's going to then receive this or customer, you have the backup, the records that shows when I handed this over, inspection tips the tips were clean, or I should not say the tips, but the connectors, the end faces were clean, and there was no scratches, there was no dirt. And that's a good thing. It's almost like a birth certificate, you can say, for your network to show that, hey, everything's good to go. Now, the one on the top right does not do pass-fail analysis, where the VIP 45 does have the pass analysis software that comes along with it when you purchase it, and that tests to an IEC spec in which the software has all that information built into it, and it will determine if this is a pass or fail based on the particulate criteria in which is pass and fail. So that's a big plus for that unit for the video inspection probe. Now I'd like to go over just general connector contaminants that we will see while we are out in the field. Simple, dirt. And dirt ranges from anything that's pollen, dirt, airborne fibers, cat hair, anything that's considered dirt and that would possibly block signal. Next you have oil. And this can range from oil that comes from your hands, because everybody's got, by nature, we all have oil on our hands just from being human. And a lot of times people will touch the end faces and it gets oil on the end of it. Oil will draw all their dirt into it and make it stick to it. But you could even be in a machine shop where they're machining a lot of parts. The oil that is used, the cutting oil, gets atomatized, and that's floating around in the air. That can land on the end of a fiber end face if you were by chance working in a machine shop for whatever reason that they had fiber connections in. So that oil will just be present there. liquid, and when we talk about liquid, this is any type of liquid. Anything is fluid, whether it's water, alcohol, cleaning fluid, anything. This isn't really contaminations, but it's problems, scratches that occur on the end faces of the fibers, whether it be from the fiber falling on the ground, improper cleaning method, anything that would cause scratches on the end of the fiber. Because the other thing that scratches do is they have it that it will allow an area that will hold dirt and will make it hard to clean. The next problem we come across is chips or pits. Mainly this is what happens when you have two fibers that are mated together that did not meet the IEC spec for protrusion of fibers. So the fiber is sticking out further than it should. Two connectors mate, and that glass that's sticking out is too far, and it kind of explodes. And I think there's a couple pictures later in the presentation here that will depict that. That's a problem. Basically, you either have to get a new connection or you have to repolish. And then an XS epoxy that was not completely polished off and somehow got around QC from your manufacturer. So any contamination in the fiber connection can cause a failure just due to the fact that full signal is not making its way through. Even microscopic dust particles can cause problems. So just because you can't see it by looking at it without a microscope doesn't mean it's not there. And again, contamination will block the signal or will cause only partial signal to get through, and it can also reflect back and it can ruin the equipment. Contamination between two fiber end faces can scratch glass just from vibration of the connectors and surrounding environment and rubbing together. It can cause scratches. An end face, I should say, dirt on the end face can actually prevent the connector, the end faces or the connectors from fully mating, causing an air gap. Again, loss, attenuation. And just remember, on single mode fiber, the core is 9 microns. So if you have a 1 micron piece of dirt, you're already going to lose 10% of your signal that's coming through. So it doesn't take a lot. Again, you can't see this dirt without a microscope, so that's why you have to use a microscope or an inspection scope to take a look at these end faces. One of the other reasons that you have to keep your end faces clean is with high-powered lasers that are used nowadays. If you have enough dirt or contamination on the end that can actually cause higher back reflection, it'll burn the end face of the fiber. And what happens is, as the signal is being passed down the fiber, it encounters this dirt, it's reflecting back. And what happens is it heats up that end of the ferrule. And sometimes that dirt will cook on, and then you can damage the connector. So higher powered lasers, there's more energy in there, it causes other problems. And you can see it said the burnt might damage the optical fiber surface enough that you can't be clean, so you got to get a new fiber. So if you've already pulled this through, 300 meters of conduit and didn't clean the end face, you could have a problem on your hands. Again, eliminate dust contamination whenever possible. You want a pristine fiber connection end. And that's how you do it, is by cleaning and inspecting, continuing to do that. So what we're going to show you here is one of the other reasons, or the other problem that occurs out in the field. Somebody may connect or clean one connector and forget to clean the connector that they are mating with. And in this case, this could kind of show this is going to illustrate this, and it's also going to illustrate something that's known as particle migration. So you can see here we have on the left a picture of what the right side looks like. The right side is going to be used as a demo, and you're going to see in a second how the connector comes in and smashes it. Okay, what happens is it smashed the two connectors came together and smashed it, and now we have more dirt. And you can see on the left-hand side after the first mate what happens. And again, that can transfer dirt from the connector that came in that was clean onto the one that was clean now, because there's stuff on the left-hand side that was dirty. You can come in again, and it comes out, and you can see that one thing kind of damaged the fiber, and you can continue to come in and smash these, and you can see how there's dirt being transferred from one to the other. Remember, the original one that came in, you look at it, we'll try it again, came in was clean, and some stayed on it, and it comes in again. And that's known as transfer, but that's what happens when you don't clean both end faces. Most of the times what happens is you clean the connector that you have out, the jumper or patch cord, and you're going to be plugging into a patch panel. You didn't clean the patch panel backside because you couldn't get that off. And there's ways of cleaning that anyway. So just remember all the reasons why you got to keep cleaning. This is the big problem here, is particle migration and transfer of dirt. If you don't clean one, if you clean one, you got to clean the other one just to be safe, and inspect it also. All right, get through this. So this is how a clean end face should look. You can see this is a single mode fiber. The chlor obviously is the middle white dot, surrounded by the cladding. And then the white area beyond that's the ferrule or ceramic end face. This is single mode. You can tell by the small size of the core. But this is what a good, pristine end face should look like. This is also a clean end face. This is multimode, and you can tell by the larger core in the middle, surrounded by the cladding. Again, that core is like 62.5 with a cladding of 125 microns around that. Now you see those, it looks like there's 3 darker dots on the right-hand side of this picture. That's probably epoxy, XS epoxy that wasn't polished off, but it's in the epoxy ring area, so that would probably pass. That generally does not affect too much of that because it's far enough away from the core, but it could cause a problem, but you know that it's there by viewing it. So now I want to show you what typical end faces look like with the particular dirt, alcohol, scratches, or solvent. That's what dirt looks like. Dirt's just kind of random. It's out there. It can be dust particles, pollen, anything that's considered dirt or contaminant. This on the other side is alcohol. We know it's alcohol because we went through and were looking for alcohol pictures when we were doing it. But you can tell this is alcohol, or I should say liquid, because of the wavy lines. It has not dried yet. So what happened is somebody was cleaning this and they went to inspect it and it was still wet. So that's what that would look like. This is a bunch of scratches, and these are, it looks like there's a whole lot of scratches here, but it's to point out the fact that scratches, this is what a scratch looks like. This is just not finished. All the steps for polishing is what that is, because you generally will never see a connector coming through like that. But you can tell that this has not been polished properly because of the black area around the cladding. That's extra epoxy that has not been finally polished off. Now you can see the dried liquid or solvent, and that's basically the top was the alcohol after the alcohol dried a little more, and still you can see there's a couple areas where it looks like it's still fluid, but that's what the drying up looks like. And what happens is when that dries up, if there was any dirt in there, it'll dry also into wherever it is and just stay there. So you got to make sure that when you're cleaning these, you clean them properly. Again, this is more dust particles, and you can see if a couple of those larger pieces of particulate got over that 9 micron core, that little white dot in the middle, you're going to lose probably all your signal. Again, here's some liquid contamination, and you can tell that this was mated And the reason you can tell that, you can see that dotted circle line around the core cladding there. What happens is, again, I was telling you about they make a physical contact. What happens is it pushes the liquid out to the point where there's no contact on the ferrule anymore, and then it dries in that area. This particular connector still has some wet alcohol or solvent in the middle, and that's from that wavy, almost fluid look. So there's a little bit of both here, some dried fluid as well as still some wet still on there. Again, here's more wet, and you can tell this was taken, it wasn't properly cleaned because it's still wet and wasn't dried off all the way. And this connector was, I guess, at some point in time wet and was mated, and you can see again that ring around there. That's where the fluid was pushed out to that, where the non-connection occurs due to the radius of curvature. Again, this needs to be cleaned again to get rid of that particulate or droplets that have dried. Here's again some dried liquid or solvent. Again, we know what a pristine connection end face should look like. We can see that this needs to be cleaned. Again, another classic example of a end face that had fluid on it, wasn't dried off or cleaned properly, and when it was mated and then we went and looked at it again, it pushed it away and it was still wet and it dried in that ring area. And here's some oil residue. This is what oil looks like, and a big telltale sign of oil is the fact that there are parallel lines here. It almost looks like streaks, and that's what you get with oil. Again, here's some scratches. This is a little better view of what scratches would look like in a normal situation, unlike the original one that had a whole bunch of scratches. You can see the scratches go through the cladding, the core, and this is just not a good thing to have on your end face. Is it can capture dust and dirt, and they can keep embedded in there, and then it can move all around. So this really should be polished further. It would not pass inspection on the IEC spec for polishing. Again, now we're looking at a little bit of a cladding damage, and the main thing that you want to see here is that chip, that lighter side on the right-hand side. This connection was made, and for whatever reason, there's still excess epoxy here. That could have been done during the termination process where there wasn't a full amount of epoxy that was put into the connection or the connector, and that caused that chipping to occur. But that's definitely, in addition to the extra epoxy that's there, that chipping is no good. So this would either need to be polished or altogether thrown out and re-terminated and put a new connector on. This is a 1.25 millimeter ferrule that was polished too much, and the reason you know that is you can see how that white area is there's a little bit of a dark area there showing. It's really pointy based on this picture. You should see all white. You shouldn't see that dark area there on the outside surrounding the cladding that you see in the middle. Now we're going to go over some cleaning procedures that are pretty basic, but you need to do it, and you need to have the proper equipment, and you need to do it in the proper manner. So this is going to go over a flow chart of how you should clean your connector end faces. Inspect it with a fibroscope or microscope. Is it clean? Pretty simple. It either is or isn't. If it is, and you've actually cleaned both sides, you can mate. If not, you go through a dry cleaning method first. Again, inspect it. Is it clean? If it is, you can mate. If both of them are clean, yeah, you can mate them. If not, go through a dry cleaning again. If that didn't work, you keep going down here. Eventually, if the dry doesn't work, you're going to have to add some solvent, and combination of solvent, dry clean. And again, you're going to have to continue to do this until you get that pristine end face. We came up with a little acronym to help you remember. You want to inspect, clean, evaluate. And this evaluation is the going back and forth. It may take 2 or 3 times to clean it, but It's just not inspect, clean, and then you're done. It's inspect, clean, evaluate, and then test. And test basically is putting it together to make sure that you have your signal that's going through. You know, iced tea, you can remember that. That's pretty easy to remember, but it kind of ties things together. Now I'm going to go over the different types of cleaning methods that we have, or that I can introduce you to. You know, you have your dry methods. And usually there's dry method and then there's a dry/wet in combination. So you have your cassette cleaners, which is a dry method. And you have lint-free wipes. Should always use lint-free wipes. Never use anything that has any lint or rags or your shirt or licking them. You know, there's people out there that'll lick them with their tongue and wipe them on their shirt because they don't have the proper cleaning equipment for them at their disposal. So when there's single wipes and as well as the box cubes that you're going to see. There's cleaning sticks, 1.25 millimeter as well as 2.5 millimeter, and that's generally for your bulkheads. Your quick clicks, or one clicks, people call them. They come both for 1.25 and 2.5 millimeter, and you can clean cable assemblies as well as the bulkheads with those. Wet methods, you got your lint-free wipe with your solvent, your cleaning sticks with your solvent. That's kind of your wet method. Now I'm going to go over what you need to do with those. And then your different types of solvents. You have your cleaner, which is a solvent base. There's some other chemicals in there. And then there's a water base. It's like 90% water and some solvents. And then of course you have your alcohol, which most people over the years have used. Problem with alcohol does leave a residue if not cleaned properly. So more and more alcohol is going away, and some of the other solvents that are better at cleaning and less caustic are coming out. Again, the water-based one we kind of use highly, or we recommend highly, just because it's, you know, it's going towards that green effort. So as you can see, there are the different cleaning methods that are up there. We have on our left-hand side. Top is the cleaning cassette. The middle is your lint-free wipes at the top, and then your cube, or your, you know, also your clean wipes that you can see there. Bottom left is your two types of cleaning sticks, which are the 2.5 and 1.25 millimeter. And then we have two quick clicks on there. We have a 1.25 millimeter quick click and also an MPO quick click. The wet methods, you can see there, you have your lint-free wipes and you use it with the solvent as well as the cleaning sticks and the cleaning solvent. One of the things you have to remember when you're using these is you put the cleaning solvent on the lint-free wipe, one area of it, clean it, clean your connector, and you want to draw your connector, you know, in one method, down or up, and then do it again, down or up. You don't only want to do it in one direction. You don't go back and forth. And then you go to a dry area on that lint-free wipe and dry off that excess liquid that does not get, you know, that you want to get off, so it's not in those other pictures that you've seen that showed it looked like it was still wet. That'll keep that from showing up or that from occurring. Same thing with your cleaning sticks at the bottom. You put a little bit of cleaning fluid on that stick, clean the adapter, and then face it on that are in these bulkheads, and then you bring a dry one and put it back in there to try to dry that out. That will really help you out. So I kind of, you know, don't allow the solvent to evaporate. It's pretty general. You're going to be cleaning it and then drying. You know, you do a wet clean and then a dry clean, and that dries it up. You know, and they say that, you know, that whatever you get on when that cleaning solvent dries, sometimes a little more difficult to get off with the contaminant. And again, where it says the solvent can remain in small crevices or cavities where it might reemerge. So you remember the split sleeve that's used inside the adapters to align the two ferrules. Sometimes the excess fluid will get trapped in that area. So that's why after you do the cleaning stick with the solvent on it, you go back with one that's dry to help clean some of that out so that does not reemerge. This is pretty straightforward. Nothing's 100% effective. That's why you have to, again, use that ICE-T method: clean, inspect, evaluate, and then test. The evaluation process, sometimes you go back a couple times. Dry method may not work, so then you got to go to the wet method. But the only way you're going to know that is by using an inspection scope. Again, improper cleaning. This is where I said don't go back and forth. You only go in one direction. Don't use the same area more than once. And remember to dry after you use the wet. And that's basically what this says. Yeah, by going over the same area, you can, get contaminant that you took off, you can put it back on again. So, storing your products, pretty straightforward. Keeps things clean. The less dust and dirt and stuff that you keep off your cleaning supplies, it'll keep it away from your fiber. So keep everything as clean as possible. Here's some safety tips. I'm going to let these scroll through. Most of them are pretty self-explanatory. That's the main one. Don't ever look into the laser or into a fiber, and always assume that there's a signal going through. Again, you're cleaning stuff. You got to make sure that you can inspect. So if you clean something and don't have a way to inspect, you're really not doing yourself a service, because you don't know, did you clean? Did you make more dirt on there? Did you move it? And did you just move the dirt around? This is more for electrical considerations. Again, make sure that when you're looking through fiber connections, you know that there is no laser radiation. Don't touch the end faces, pretty straightforward. Never pull by the cable itself. There's always the connector housing that you want to pull on. Again, don't reuse old stuff. You're just going to be transferring, moving dirt around. Same thing about that. Yeah, alcohol, yeah, it's flammable, so be careful. Here's some other tips we got for you. And again, I'm going to scroll through these. Everybody can read. I don't need to read for you. Safety goggles are important. Can't hurt. Again, this is that. Again, always inspect your connectors or adapters before you clean and after you clean them. That brings us to the end of the webinar. Not sure if anybody has any questions. Be free to answer any. If you need to get in touch with me, you can always email sales@fiberoptic.com. Direct them that Joe Cairone did the webinar and you have some questions for him. I act as the technical support for the sales group. And I am free to answer any questions anytime that they get posed during the day. You come up with a question that you're just not sure about, and you want to bounce it off me, I'll be sure to help you out. I hope I answered and informed you on cleaning and connector inspection, and I thank you for joining the webinar. Have a great day.